You are watching channel Number Collage. Through this channel, we make sincere efforts to make you understand and like mathematics in a simple and easy manner. We need your cooperation in this regard. In this video, we will understand the discontinuity of a function. In our previous video, we have seen that a function fx is continuous at x equals c if number 1, fc exists or defined, which means the value of the function at x equal to c is defined or therefore it is existed. Number 2, limit of the function as x approaches c exists, that is, the left hand limit as x approaches c minus is equal to right hand limit as x approaches c plus. And number 3, limit fx as x approaches c equals the value of the function at x equals c, that is f of c. If any of the above conditions is not satisfied, the function is said to be not continuous or discontinuous at x equals c. Now we will study the conditions under which a function is not continuous. Suppose a function fx is defined at x equals c, that is, f of c exists. The discontinuity may be possible due to any of the following reasons. Number 1, either of limit fx as x approaches c negative and limit fx as x approaches c positive, or both of them may not exist. Number 2, limit fx as x approaches c negative and limit fx as x approaches c positive, both of them exist but may not be equal to each other. Number 3, limit fx as x approaches c negative and limit fx as x approaches c positive both exist, but they may not be equal to f of c. Now we will study if a function is discontinuous at x equal to c, then can we remove this discontinuity, if at all, and in what situations this discontinuity can be removed? Yes, there are situations in which we can remove this discontinuity, and there are situations in which we cannot remove the discontinuity. First, we will study the situations in which the discontinuity can be removed, and it is known as removable discontinuity. For a real valued function f of x, if f of c exists but number 2, limit fx as x approaches c is not equal to f of c, then f is said to have removable discontinuity at x equals c. Since limit fx as x approaches c exists, this discontinuity can be removed by redefining f at x equals c such that f of c equals limit fx as x approaches c. Discuss the continuity of function fx, which is defined as fx equals a rational function for x not equal to 0, fx is a constant function phi for x not equal to 0. Let us draw the graph of this function. Here the value of the function at x equals 2 is 5, that is f of 2 is 5, which means that the point 2, 5 lies on the function. It has been shown by a solid point. Now fx equals this rational function. The numerator can be factorized as x minus 2 multiplied by x plus 2. Here, since x not equal to 2, x minus 2 is not equal to 0, so x minus 2 can be cancelled. So fx becomes x plus 2. Its graph will be like this. Now since x is not equal to 2, we can find the limit of the function as x approaches 2 as limit of x plus 2 as x approaches 2. We will replace x by 2, so it will be 4. Now since x is not equal to 2, the point 2, 4 will be a hollow point like this, and it will not lie on the graph of the function. Here, limit of x as x approaches 2 is 4, and f of 2 is 5. Therefore, limit is not equal to value of the function at x equals 2. So there will be a break in the graph of this function at point 2, 4. Hence, function f is discontinuous at x equals 2. Since limit of fx as x approaches 2 exists, the discontinuity of this function is removable. We can remove the discontinuity by redefining f of 2 as f of 2 equals 4, because limit of fx as x approaches 2 is 4. Now the function becomes continuous at x equals 2, because the point 2, 4 lies on the graph of the function. So the continuity has been removed now. Examine the continuity of the function at x equals 3. Function is defined as fx is a rational function when x not equal to 3, and fx is 0 when x equals 3. Here, value of the function for x equals 3 is 0. Therefore, f of 3 is 0. Now, we will factorize the numerator. It will become x minus 3 into x minus 4. And the factors of denominator will be x minus 3 and x minus 2. Now since x is not equal to 3, x minus 3 is not equal to 0, so we can cancel x minus 3 factor from numerator and denominator, and fx becomes x minus 4 divided by x minus 2, because x is not equal to 3. Now the limit of the function as x approaches 3 will be, because see here x is not equal to 3, so x approaches 3, it will be x minus 4 divided by x minus 2. We will replace these x with 3, so it will be 3 minus 4 divided by 3 minus 2, which will be minus 1 divided by 1, which will be 1, which will be minus 1. Now limit of fx as x approaches 3 is minus 1, and f of 3 is equal to 3. Therefore, limit fx as x approaches 3 is not equal to f of 3, which implies that fx is discontinuous at x equals 3. Now, since limit of the function exists, we can remove the discontinuity of the function, and to remove the discontinuity, we will redefine f of 3 equals minus 1. It was 0 previously. Now, limit as x approaches 3 of fx becomes f of 3, which is minus 1, which implies fx is continuous at x equals 3. Examine the continuity of fx at x equals 3. Fx is defined as this function for x not equal to 4 and fx equals 0 when x is 4. Here f of 4 is 0, that is, the value of the function at x equals 4 is 0. Now we will simplify this function. First we will take x common from the numerator. We will get x multiplied by x cube minus 4 cube. After that, we see a radical term in the denominator of this function. Therefore, we will multiply the numerator and denominator by the conjugate of the denominator, which is under root x square plus 9 plus 5. In the next step, we will factorize x cube minus 4 cube according to the identity that we have. A cube minus b cube equals a minus b multiplied by a squared plus ab plus b squared. So x cube minus 4 cube will be x minus 4 multiplied by x squared plus 4x plus 4 squared. After that, we will multiply the denominator separately. Here, this will be according to a minus b multiplied by a plus b, which is a squared minus b squared. So a squared will be x squared plus 9 and b squared will be 5 squared, that is 25. So 9 minus 25 will be minus 16. So this product will work out to be x squared minus 16, which can be further factorized as x minus 4 multiplied by x plus 4. Here x is not equal to 4, therefore x minus 4 will not be 0. So we can cancel x minus 4 from numerator and denominator. So the function that we get, we will take the limit of that function, which will be limit of x as x approaches 4 will be this part. We will solve this limit by replacing x by 4. We have replaced 4 in place of x. Now this bracket will be 48, this bracket will be 10, and this bracket will be 8. 48 divided by 8 will be 6. 4 multiplied by 6 will be 24. 24 multiplied by 10 will be 240. So the limit of x as x approaches 4 will be 240. And we have already found f of 4 equals 0. And we observe that limit of x as x approaches 4 is not equal to f of 4. Therefore, we can say that fx is discontinuous at x equals 3. Now, if we want to remove the discontinuity, then we have to redefine the function at f of 4 as 240, so that the limit of x as x approaches 4 will become f of 4, which will be 240, and we will have fx to be continuous at x equals 4. If function fx is continuous at x equals 0, where function fx is defined as this function when x not equal to 0 and fx is 2, when x equals 2. We have to find the value of k. Here f of 0 is 2, that is the value of the function at x equals 0 is 2. Here fx is 8 to the power x minus 2 to the power x divided by k to the power x minus 1. First we will write this 8 as 2 multiplied by 4. We will write this as 2 to the power x multiplied by 4 to the power x. After that we will take 2 to the power x common. We will write this function as 2 to the power x multiplied by 4 to the power x minus 1 divided by x divided by k to the power x minus 1 divided by x, because we are bringing this function in a particular form whose limit can be found out. Since fx is continuous at x equals 0, we know that limit of x as x approaches 0 is f of 0, that is the value of the function at x equals 0. So limit of this function will be 2, because f of 0 is 2. We'll solve this limit by substituting 0 in place of x. Limit of this function and this function will be log 4 and log k according to the limit formula that we have. Limit a to the power x minus 1 divided by x as x approaches 0 is log a. 2 to the power 0 will be 1. So the limit 1 as x approaches 0 will be 1. Log 4 can be written as 2 log 2, because 4 can be written as 2 squared and the power will come as a multiplying factor here according to the rules of logarithm. After that, this 2 will get cancelled with this 2, and what remains is log 2 divided by log k equals 1. We will cross multiply, that will give us log k equals log 2, which implies k equals 2. So this is the value of the unknown k. Now we will understand what is meant by irremovable discontinuity. If a function is discontinuous at x equals c, then this discontinuity cannot be removed if limit of the function as x approaches c does not exist. For a real valued function fx, if number 1 fc exists, number 2 limit fx as x approaches c negative is not equal to limit fx as x approaches c positive, that is limit fx as x approaches c does not exist because the left hand limit is not equal to the right hand limit. Then we say that f has irremovable discontinuity at x equals c. Since limit of x as x approaches c does not exist, this discontinuity cannot be removed. Discuss the continuity of fx equals x plus 2 when x equals 4 or x less than 4. Fx equals x plus 4 when x is greater than 4. Let us draw the graph of this function. Now, since x is less than 4, the left hand limit will be limit of x as x approaches 4 negative. It will be limit of x plus 2 as x approaches 4 negative, which will be 4 plus 2, 6. Now since x is equal to 4, limit is equal to 6, therefore the point 4, 6 will lie on the graph of this function. And the graph will be like this: f of x equals x plus 2. Now right hand limit will be limit of x as x approaches 4 positive. It will be limit of x plus 4 as x approaches 4 positive will be 4 plus 4, which will be 8. But since x is greater than 4 when y is equal to 8, the point 4, 0 will not lie on the graph of the function. Hence, it has been shown by a hollow point. The graph of the function when x is greater than 4 will be f of x equals x plus 2. Now limit fx as x approaches 4 negative, which is 6, and limit fx as x approaches 4 positive, which is 8. Since these two limits are not equal, which means that limit fx as x approaches c does not exist, which implies the function fx is not continuous at x equals 4. In this case, there is no need to find f of 4. In this case, since limit fx as x approaches 4 does not exist, we can say that f of x has irremovable discontinuity at x equals 4, because here the left hand limit is 6, right hand limit is 8. They are not equal, therefore the limit does not exist. In this example, the piecewise function is, we must note that f of 0 equals 1, which means the value of function fx at x equals 0 is 1. Left hand limit is 1, right hand limit is 2. Since left hand limit is not equal to right hand limit, limit of function fx as x approaches 0 does not exist. Which means that function f is not continuous at x equals 0. In this case, since limit fx as x approaches 0 does not exist, we can say that fx has irremovable discontinuity at x equals 4. See here, left hand limit is 1, right hand limit is 2. They are not equal, therefore the limit fx as x approaches 0 does not exist. Discuss the continuity of fx at x equals 2. The function is defined as y equals 1 when x is between 1 and 2, y equals 2 when x is between 2 and 3. Let us draw the graph of the function. When x equals 1, y equals 1, therefore the point 1, 1 will lie on the graph of the function, hence it has been shown by a solid point. The graph of y equals 1 will be a horizontal line which will emerge from the point 1, 1, and since x is greater than 1, it will extend to the positive direction of x-axis up to the line x equals 2. Now, when x is less than 2, y equals 2, and when x is less than 2, x is not equal to 2, therefore the point 2, 2 will not lie on the graph of the function, hence it has been shown by a hollow point. Now the graph of y equals 2 will be a horizontal line which will emerge from this hollow point 2, 1 because x is less than 2, and since x is greater than 2 and it will emerge from the hollow point 2, 1 and extend towards the positive x direction up to the line x equals 3. Here the left hand limit is 1 and right hand limit is 2. Left hand limit is 1, right hand limit is 2. Since left hand limit is not equal to right hand limit, which implies that limit of x as x approaches 2 does not exist, which means that fx is not continuous at x equals 2, and since limit of x as x approaches 2 does not exist, this discontinuity cannot be removed at x equals 2. Therefore, this discontinuity is irremovable. In this video, we have understood a function is discontinuous when limit of fx as x approaches c is not equal to the value of the function at x equals c. This type of discontinuity can be made continuous by redefining the function as f of c equals limit of x as x approaches c. In case of irremovable discontinuity, we have seen that a function is discontinuous if limit of x as x approaches c does not exist. In this case, we cannot remove the discontinuity, hence it is called irremovable discontinuity. Hope you liked our video. If you did, please click like and share this video, subscribe our channel, and thanks for watching. Have a nice day ahead.